All right. Now we're going to talk about using some substitution to solve systems of equations, which I'm very excited about here. And so here are 4 systems equations we saw earlier. Solve each system, then check your solutions by either graphing them on Desmos or substituting them into the original equations to see if they are true, if the equations are true. All right, so what does that mean? Okay, solve the system. All right, so let's remember what that means. So when we solve a system, we're going to find the xy ordered pair that makes both equations true, that works. All right, so that's what we really want. We want an x and a y value that would make both of the equations true. So when we were solving with graphing, we were looking for that intersection point between the two lines. And we know if a point, let's say that was the point like 2, 4, if that point was on both of the lines, which it is if it's the intersection point, that means if we put 2 and 4 in for x and y into both equations, it will work. It will make a true statement in both equations. But what if we don't have a graph? Well, we can use an algebraic method called substitution. And substitution works when we have one of the equations as a solved for x or solved for y. So notice in this first example that this second equation is already solved for x. All right, we know x is equal to -5. And so the question is, then what is the y? So if we take that -5, what we can do with it is take it and put it into the other equation. We can substitute it in and say, okay, well, what if x is -5? Let's put -5 in for x and see what y is. So that's what we're going to do here. We're going to put that, and this is called substituting. So we're going to substitute -5 in for x. All right, so let's rewrite that equation. So then that equation becomes -5 plus 2y equals 8. And now we just use our solving steps, right? So now if we're solving for y, and we're going to get y by itself. So let's start off by undoing the subtracting of 5, the -5, by adding 5 to both sides. So that leaves us with 2y equals 13. 8 plus 5 is 13. And then 2 times y equals 13. So to undo there, 2 times what is 13? Well, if I divide both sides by 2 to undo the multiplication, that means y is equal to 6.5. So now notice I have both of the values. I knew that x was -5, and now I know my y is 6.5. So that should be the solution, the x and the y value, x being -5 and y being 6.5. So what we can do is now let's go into Desmos and actually see, do these lines cross at -5, 6.5? Because that's how we can check our work. Make sure that we did all that math, that awesome math, correctly. So let's go into Desmos. And this is what I recommend that you do every time you do problems like this and check your answers. So x plus 2y equals 8 was our, that didn't turn out, did it? Let's try that again. So x plus 2y equals 8. All right, that was our first equation. And then the second equation was x equals -5. And I think, let's see, we'll just hit the -5. Yeah, that works. All right, so then we can just kind of adjust our graph here. Notice that we have these two lines. If we touch that intersection point, there it is. -5, 6.5, which was our solution. Bingo. Let's do a screenshot of that value right there. And then we can bring that in. Okay, let's just crop it a little bit here. Save it to photos, come back to Notability. Let's drop that in. I'm going to bring it in like the bottom of the page here. All right, let's see if I can drop that down to the bottom here. And this is just showing, let's make it small enough that I can fit it on the page. I'm going to have to fit like 4 graphs here, so I'm going to make this really small, and it's just as a reference to show that I did check my answer. -5, 6.5 is exactly what I had. Sweet. Okay, let's go to B. All right, B. Now, again, we're looking for in this method to start off, we need one of the equations solved for a variable. And you'll notice in this equation, we have the second equation is solved for y. We have y by itself. Actually, in both equations, never mind, both equations were solved for y. So we could actually do this a couple different ways. I'm going to do it kind of like I did on the first one, though. So if y is equal to -1, that means I can substitute it in the first equation for y, right? Because y is equal to -1, so I can put -1 in for y. So substitute -1 for y. And then let's rewrite that equation. So then that becomes -1 equals -7x plus 13 when I put that substitution in there. And so now I already know the y value is -1, by the way. So I can actually think about that over here. I know y is equal to -1. I have half of my solution right off the start. Let's figure out what x is. So if I'm solving for x, let's see. X is on the right side of the equation, so I've got to move everything over to the left side. Let's start off by subtracting 13 from both sides. -1 minus 13 is -14, equals -7x over here. And then that's -7 times x. So to undo multiplication, we will divide both sides, in this case by -7, which is equal to +1x. And then over on the other side, -14 divided by -7 is +2. So x equals 2 and y equals -1, which means that our solution should be 2, -1. In other words, that should be the intersection of the two lines. Let's go see. Back over to Desmos. We'll erase the lines that are there if I can get it to delete. There we go. So our first line was y equals -7x plus 13. And then the second one was y equals -1. All right, so let's just look. Here's my two lines. I can see it looks like they're crossing right here. Let me just touch on that. 2, -1, which is, I believe, what we had, right? All right, let's take that. Let's crop that up. You guys get good at this. All right, done. Saved photos. Here we go. Back over. All right, bring that down. So we checked our answer. Again, this was the check your answer part of the problem here, so we're just going to drop that in to show that we checked our answers. All right, switch colors. Let's go with the next one. All right. So C is a little bit different here. Neither one of these is solved for one of the variables, so this makes this a little bit tricky. There's a couple ways of doing this, but if this were a problem, I would probably go ahead and solve one of the variables first. You know what? I'm going to go over to D first. Let's come back to C. Because I notice in D, this equation here is solved for y. It's y equals 2x minus 7. And so if it's solved for y, that means I can take what y is equal to and I can put it in for y in the second equation. So substitute 2x minus 7 for y, because y is equal to that. So I can take that whole 2x minus 7 and put it in for y. And now I have 4 plus 2x minus 7 equals 12. All right, so now I have to do a little bit more work on this one because I don't just have the x or the y straight off. So in this case, I got to solve for x here first. So I'm going to do a little bit of solving. And let's see, I have a little bit of combining like terms that I can do first here. The parentheses actually isn't really needed at this point because there's not a number in front of it that's being multiplied with the distributive property. But I can combine that 4 plus negative 7. So I can combine these two terms together. 4 plus negative 7 is negative 3. So I can take the negative 7 and the 4 and add them together. 4 plus negative 7 is negative 3. So I have negative 3 plus 2x is equal to 12. And let's keep solving. So now we'll add 3 to both sides. So 2x is equal to 15. And then dividing by 2, get x is equal to 7.5. All right, so it looks like the x value is 7.5. I don't have the y value yet, though. All right, so I have to do a little bit of work on this one first. And so I've got x is equal to 7.5. Now, back at the beginning of the problem here, I had this equation, y equals 2x minus 7. So I'm going to actually use that one down below here. So if y is equal to 2x minus 7, now I can substitute that 7.5 in for x, because I know x is equal to 7.5. So 2 times 7.5 minus 7, which is equal to 15 minus 7, which is equal to 8. So in this case, it was just a matter of like essentially plugging in that x value that I solved for into that other equation to figure out what the y value is. So the y value is 8. So my x value was 7.5 and my y value was 8. Let's check that out. Let's see if that was actually correct. All right, so y equals 2x minus 7 was one equation, and the other one was 4 plus y equals 12. All right, so see my two lines cross right up here. They cross at 7.5 and 8. So it looks like my solution is correct. Just gonna quietly add this in here. You guys have heard me talk through those steps before. Okay, so that was our fourth one. Okay. All right, now the C, the one that I have left here, there's actually a couple ways of doing this. One way of doing it is actually what I just did on the previous one, and that is to, well, actually I didn't even do it on the previous one, but you could get x by itself or y by itself on this one and plug that in. This one's kind of a unusual case, but what I'm noticing is both of the equations have a 3x, and the first one has 3x equal to 8. So since 3x is equal to 8, that could actually be the substitution that I make right here. So if 3x is equal to 8, that means I can take that 8 and put it in for 3x in the second equation, which means that whole 3x is substituted in, or the 8 is substituted in for 3x. And so I get 8 plus y is equal to 15. And now look how quick and easy this is, right? So now solving this, I get y is equal to 7. All right, so I've got the y value of my solution, which is 7. And so if I take and look at my second equation, 3x plus y is equal to 15. Now, since I know y is equal to 7, I can put 7 in for y in that equation. So it becomes 3x plus 7 equals 15. So now I'm solving for x. Subtracting 7 from both sides, I get 3x is equal to 8, which is actually what I had up here, and I could have actually gotten this right at the start, but let's just keep going. And dividing by 3, I get x is equal to 8/3. So my solution, 8 divided by 3, which by the way is 2.6 repeating, 2 2/3. And so 8/3, 7 should be my solution. X equals 8/3 and y equals 7. And if I'm checking my answers like I did on the other ones, we'll remove those two. So 3x equals 8. Let's try that again. Equals 8. And then my second equation was 3x plus y equals 15. And all right, here's my two lines. I can see that they cross right there. And there it is, 2.6 repeating, comma 7. So in other words, 2 and 2/3, 7 is where those two cross. All right, guys, so that was 4 problems, and that's a very mathy sort of page right there. For a math teacher, that's super exciting stuff. So there were a couple that were kind of pretty straightforward problems, the first couple, and then the last couple were a little bit more challenging. But hopefully with that number of examples, that's starting to make a little bit of sense. And what I want you to remember is for every single one of these problems, we're trying to find the x and the y that is on both of the lines. It works in both of the equations. And so once we solve for it using an algebraic method, we can quickly check using Desmos and see, is that truly the place where the two lines cross? And if it is, then you have done the work correctly. If it turns out that they intersect in a completely different spot than what your answer says, then you must have either done a little bit of the algebra wrong, or maybe you typed the equations in wrong in Desmos. But use Desmos as a good check.